Okay, so I'm just going to go on further from what I talked about this morning. So, what if we could achieve a 30% reduction in engineering? What if we could achieve 60% reduction in engineering cabinets and field terminations? What if we could be virtually free from dependencies with other disciplines? What if we could eliminate hardware FATs? What if we could reduce commissioning time by 30%? What if we could make the installation almost construction-proof? And then what if it just happened? So that's what we've been trying to work towards. So we went through these 12 challenges this morning, so I won't go over them again, but these are the things that we were trying to achieve by the technologies that we wanted the suppliers to offer us. And so as it turns out, in the things that we're implementing, most of these are being addressed. The real key is that we're really challenging the way that we've always done things. We've asked our group to really step back. Don't start from what we're doing today and figure out what we can do to be better. We need to step way back and say, let's look at another way to do it. And so as we've done that, we've realized that there's certain things that we just don't have to do anymore. So one of them related to schedule. So our schedules are very sequential. We don't have a choice using the conventional architecture. We have to have all the design information. We'd like to get it all at one time, but that never happens. But we have to get the design information. We then have to design the system. And then we continue to get changes while we're designing. And then we have to fabricate the system. And then we have to conduct an FAT. And hopefully we've got the design complete, but usually, in fact, I think on our projects we've never had the design complete at FAT. So we then FAT the system, at least a portion of it, send it to site, it gets installed. We end up having mod packs where we're making modifications that are different from the FAT, and it messes up the FAT, and then we have to do site acceptance testing. So it's very sequential, and there really isn't any way to do anything in parallel. And so it's just the issue is really management of change. How do we manage all the changes that are taking place? And it's a challenge. We've thought that if we had the best processes, if we had the best people, if we had the best technologies, then we could be successful. What we've realized is we can have all those things and still not achieve what we want to achieve. We'll still be on the critical path. We'll have to go to extraordinary measures at the end of the job to stay on track. And the message we're delivering now is that we don't want to go to extraordinary measures anymore. These things ought to happen, and it ought to happen such that we don't have to dump people on at the end of the job. We're not doing a lot of rework. And so now we've come up with this idea of this lean project execution, where we can separate the physical system from the soft system or software, which allows us to actually separate the activities and run them in parallel and bring them together at the last moment if we wanted to, but at a later time. We don't have to do it initially. So if we leverage Smart I/O, then we can start eliminating marshalling cabinets. We can actually shift the late binding to later, actually at the site. We eliminate cabinets, we eliminate termination, we're eliminating complexity. And then we can actually prove the software virtually, such that when we do put them together, they just work. There's nothing we have to do to make it work. So that's where we're headed. So you could take the traditional waterfall schedule that shows how everything's tied together, and you can come up with a much shorter schedule. Now, we may not change the schedule of the project because there could be other things that are driving the schedule. But I sure like the situation where we're not driving the schedule. We want the process guys or the machinery guys or the piping guys, let them drive the schedule. In fact, the message that I've told the folks in my group who are assigned to projects is that we want them to become the unknown engineer. Nobody hears about them because there's nothing that needs to be elevated because this stuff just happens. So this talks about what late binding accomplishes. It allows us to manage budget, manage risk. We can synchronize as changes take place. We can do a lot of work in the cloud, software such that it's being done wherever it's most cost effective to be done. We don't have to bring the team to a particular location. We could have people working in India. We could have them working in Australia. We can have them working wherever it makes sense. And then we take advantage of smart I/O, virtualization, and then cloud engineering. And so this is a symbol we came to show the combination of these three things to achieve our objectives. So this slide talks about the smart I/O, and so this just shows a traditional conventional installation. And then we can eliminate many components such that it's much simpler. There's not a lot of field construction work is significantly reduced. The assembly work is significantly reduced. The engineering is significantly reduced because we're not engineering cabinets. And even the smart junction boxes are part number mass-produced items. So there's no engineering there as well. And so we can reduce the functional design dependencies. So we can wait until we get all of the design data from our process engineers and our mechanical engineers and our machinery engineers. Before, we had to have all the software completed, and we have to have all the design details completed prior to FAT. With this approach, with all the customization being in the software, it doesn't have to be right until we're ready to commission it. So we've got all of construction to get the software right. So this allows us to manage schedule much better. And we do take advantage of the virtualization, not only from a component, so we're consolidating PCs into servers, but we're also doing it in the design development. And so this slide just shows about what we're doing with virtualization. So this will greatly reduce the footprint. It also provides a lot of benefits to operations by the fact that we've virtualized a lot of the hardware. We're less susceptible to all the version churn that takes place. And then again, I talked about using the virtual server farms such that the work can be done wherever it's cost effective to be done. No longer do we have to bring people all to one location. You know, there's been a view for many years that when we have an automation provider, we have to watch them doing everything. That it's the only way we can assure ourselves that they're working efficiently. That's just a paradigm that we need to overcome. All of these guys, all of our automation providers want to work as efficiently as possible. And so we need to facilitate doing it in the most cost-effective way. And if it can be done in some low-cost energy center, then that's where it ought to be done. And so just in summary, the question shouldn't be what if. The question should be why not. And so here's a symbol that we've put together for lean project execution on top of the other components, the smart I/O, the virtualization, and the cloud engineering. It gets us to the point of it just happens. So, okay, thank you.